In this video, we will talk about a quite necessary thing about lists. And secondly, we will talk about strings again, because strings are like lists. A list is a data structure, an array, or some kind of a container that contains references to other objects. And we can use an object that is stored in a list by using the number of its place in the list, from 0 to infinity. It's like an index of a book, the title of a chapter and opposite the page number. Lists can be compared with the lists themselves that we compose every day. A purchase list, a to-do list, and so on. Fits very well with the idea of lists, an example of an egg box. These boxes. Such a box is a list, and the eggs in a box are the data in that list. The analogy will be almost 100% complete if each cell will be numbered from 0 to 10. I think the main idea is clear. Back to Python. A literal, that is a syntax that creates an object, is square brackets. Elements of a list should be separated by commas. It's a list of integers. Lists can be mixed in terms of their elements type. For example, this is also a list. Everything, of course, depends on the situation and tasks, but I think I will not be mistaken if I say that most often the list contains elements belonging to the same data type. Strings, for example, or a list of posts, or list of comments, etc. So let's create a list, and it will be a list of strings. The L list will contain such elements A, B, C, and D. You can get a list item by its index. First of all, I refer to the name that refers to the list. I use L. After that, immediately put square brackets without spaces, and inside the bracket I have to use the index number of the element I want to get. 0 is the first element. It's A. If I access a non-existent element, say at index 12, then I get this exception, list index out of range. The valid index range will be from 0, from the first element of the list, to the last element. The index of the last element can be found like this. We pass the list to the len function, as we did with the strings. It will return the total number of items in the list. We can see that the L list has 4 elements. We know that the indexes start counting from 0, which means that the index of the last element will be 1 less than the length of the list. So length of the L list minus 1. And the 3 is the index of the last element. So to get the last element by its index, this expression can be passed in the square brackets. Firstly, Python will get the length of the L list. Then it will get an index of the last element of the list, minus 1. And at last it will get the element itself. The length minus 1 is the index of the last element that will be passed into the square brackets to get the last element itself. D, the last element. Agree that this expression is monstrous and it's hard to read. Therefore, in Python, the index of the last element is simply minus 1. The penultimate element is minus 2, and so on. This is called a syntactic sugar for this previous expression. But technically, all indexes with minus are the subtraction from a list length. Okay, we can get not only one element of a list, but a group of elements in a certain range, from one index to another. This is a so-called slicing. This is done in the usual way like in math. 1:3, and here I said that I want all the elements starting from the element at index 1, that is from the second element, and up to the element at index 3. Up to 3 is 2. And I got a list with B and C elements. If you need to specify a range of elements from a certain index to the end, then the second index after the colon should be omitted. And in a similar way, when you need all the elements up to a certain one, for example to the last element, the first index before the colon should be omitted. There also can be a third element, a step that needs to select elements from the list. Let's say I want to get all the elements from the beginning up to the last element with a step of 2, that is through 1. The first element, first index is omitted up to the last element with a step 2. And I got A and C. Okay, let's look at the list attributes. There are quite few methods. This is because a list is a container for storing other objects, or rather for storing references to other objects. The main methods that are needed very often are append and extend. Append method appends a new element to the end of the list, and extend method extends the list with another list. Let's create the L1 list. It will be an empty list. Now I want to put in the list some values. If we have all the values at once, then we can create a list with the data right away, as we did earlier with the L list. But often the data for the list may appear later, and to add the data to the list we can use the append method. L1 append, and we can see that the A string was appended to the L1 list. How do the extend method works then? Okay, let's create another list, L2. It will be 1, 2, 3, 4, 5 elements. Let's suppose I want to insert the elements of the list L2 and L1 into the list L. If I do this with the append method, I'll get a list of lists. L append L1, L append L2. I've got a list of lists with 2 elements. The first element is a list with AB values, and the second list is a list of integers from 1 to 5. But I just need a list of objects from these 2 lists. This is where the extend method comes in. L extend with the L1, L extend with the L2. And I got a flat list, not a list of lists as in the case with the append method. Alternatively, the plus operator can be used for the same purposes. But this is a less visual method, and somehow it's not really used. And by the name of the method, it is immediately clear what's going on. The list is a mutable object, unlike the same strings. This is an important property to keep in mind. I want to demonstrate this. So let's create the x variable. It will be an integer. And I want to assign the x variable as the value to the y variable. And let's get the ID. And we can see that both x and y variables are referring to the same object. Then let's increment x by 1. X plus 1. It's 4. The adding operation will return a new integer object that I want to save to the x variable again. So x equals to x plus 1. Or we can use this expression. Plus equals 1. The same. Now x is 4, and now let's look at the IDs of x and y variables. ID x, ID y. Integers are immutable objects. Therefore, when I added 1 to x, another integer object was created and then it was assigned to the x variable. But the y variable itself remained unchanged. Therefore, the idea of the variables x and y have become different. The same will happen with the strings. Now lists. I'll do a similar thing. Let's create a new empty list, L, and a new list that gets as the value L list. Let's get their ID, ID new, ID L. We can see that both variables are referring to the same list object. So let's append the A to the new list. Right? Okay, what's the list in the L variable now? And we can see that the content of the list L has changed. There is a new element which we added to the new list. ID match. These variables refer to the same object. So lists are mutable objects, and thus no brand new list object is created. The order of the elements in the list matters. Lists are always ordered. That is, the order of the list items is always preserved. There are two ways to sort lists in Python. The first way is to use the sorted function, or we can use the sort method of lists. They work in almost the same way with one significant difference. The sorted function returns a new list object with ordered elements, and the old list remains unchanged. X, A, D, C, O. Let's get its ID. Now let's save the sorted list to the sorted L variable. I am calling the sorted function and pass into it the L variable, the L list. I got the sorted L list, and let's get its ID. And the ID is different. That is, these are two different objects. And the sort method of lists modifies the list object itself. So I have unsorted L list. ID of L is 856. Then I'm calling the sort method. We can see sorted list, and ID of L is the same. We will dwell on sorting for now and return to it a little bit later. And now it's time to talk about strings again, but this time in connection with lists. Strings are similar to lists. Both are sequences of some elements. Since they have common features, the methods of working with them are generally similar. For example, strings have the split method that allows you to turn some string into a list of elements. By default, elements are divided by space, line break, etc. For example, let's create some string. The \n is a carriage returned to another line, that is a new line character. Okay, now let's create a new variable, s2 for example, and it will be the result of the split method. Sorry, s2. And we got a list of strings where each string is a word in our phrase. The split method can take as an argument a criterion by which the string will be split into elements. For example, if I pass into the split method a new line character \n as an argument, then I will get a list with only 3 elements. So, and backwards you can make a string from a list. Let's suppose I want to concatenate a list of words into one string. Let's create an empty string and call the join method. And as an argument, we need to specify which list we will join. I want to join the L list. And let's save it to a string. And let's print it. I got a string ABCD without spaces. To combine a list with the spaces, the string should contain the separating character. So if I want to have spaces here, my string should have space, or comma with a space, or underscore, or dash, and so on. In fact, this topic is also one of the main ones, since any parsing is tied to this. By the way, look at my practical Python web scraping course. It's a good place to start get a lot of practice, with the strings especially. As we know what the split method does, we can go back to sorting. Both sorted function and the sort method can take as an argument a criterion by which to sort. The key parameter is responsible for this. Let's suppose that we have a list of children's last names with the year of birth. Please note that I wrote Holmes' last name with a capital letter. By default, strings are sorted alphabetically. In this case, the case of letters matters. Let's sort this list. Will be the result of the sorted function, and I am passing into it the children list. And we got the sorted list, and we can see that the last name Holmes came up first before Chaplin, which begins with a C. The rest of the last names are strictly alphabetical. Jackson, Johnson. For this reason, it is advisable to lowercase the strings before sorting lists. That is, we have to use the lower method. So let's make it lowercase. And now I want to sort this children list by the year of birth, but not the last names. To do this, in the key parameter of the sort method or the sorted function, we need to pass a certain criterion by which the sorting will take place. I mean that we have to use some filtering function that performs some checking and returning data as a result. And on the basis of this data, we will sort the list. I wanted to sort children lists by year of birth, so let's create such a filtering function and name it just by year, for example. Def by year. and it will take a name as an argument. First of all, I have to get the year of birth, and so I have to use the split method. Equals to name, then I'm calling the split method, and I want to use an underscore as a separator, and as a result I will get a list of two elements, the last name and the year of birth. Let's print it to be sure. And then I have to call it. I call the by year function, and let's pass into it the first element of the children list. Okay, we got a list with the two elements, and I need the last one. So this expression returns a list, and then I'm using the last element. Let's print it again, and I got the year of birth. So let's return this value, year, return year, or we can use just this expression, return the result of this expression. And now we can pass the by year function to the sorted function as the value of the key parameter. So I'm adding the key parameter, and its value will be the by year function. Please note that I do not put here parentheses, otherwise it will be a function call. Here I just pass the object of the function. So let's print the sorted children list. And let's run the code. And we got a list of children's sorted by the year of birth. 10, 12, 15, 16. We can't sort items in lists if lists contain mixed data. We can sort a list only if its elements can be compared with each other, according to the common criterion for all of them. That is, I can't sort this L list with 1, 2, 3, A, B elements, because it is impossible to compare the integers and strings. Lists and strings are so-called iterable objects, and we will talk about this in connection with the use of loops. In the next video we will talk about for loop. If you like the video, please leave a like and subscribe to the channel. Thanks for watching.